Okay, let's start with number 11. So over here it says on the axis provided, sketch a slope field for the given differential equation at the 12 points indicated. So I already constructed my table with those 12 points, starting with -1, 3. So now what we're going to do is we're just going to square the x and multiply by 1 less than the y. So squaring the x in this entire column right here, these first 4 will give me +1. So multiplying that by y minus 1, I can just go y minus 1. So 3 minus 1 is 2, 2 minus 1 is 1, 1 minus 1 is 0, 0 minus 1 is -1. If x is 0, x squared times I don't care is going to give me 0. So all 4 of these just become 0. And then 1 squared is 1. So again, same type of thing. All I need to do is y minus 1. So I get the same 4 values that we had up here of 2, 1, 0, and -1. So now what I'm going to do is come over here and plot little slopes or segments that have the slope of 2. So again, if you just kind of imagine connecting this dot right here to this dot up here, that would have a slope of 2. So as you try to construct your graph through that, you can just imagine a line looking something like this. Now this one here has to have a slope of 1, so I want it pointing basically right at the 3. Slope of 0, and a slope of -1. Everything on the y-axis with an x-coordinate of 0 has a slope of 0. So little horizontal lines. My suggestion as you get down here is put that line just slightly above the x-axis so it's clear that there is something there. And then over here we have the same slope, so a slope of 2, a slope of 1, a slope of 0, and a slope of -1. And recall, they're really not judging specifically whether this has an exact slope of 2. They just want to make sure that it's steeper than a slope of 1. And if somewhere we had a slope of 3, that would even be steeper than that. So this is a pretty good slope field, so we can go ahead and move on to part 2. While the slope field in part A is drawn on only 12 points, it is defined for every point in the xy plane. Describe all the points in the xy plane for which the slopes are positive. So we could say that dy dx is always going to be positive when? Well, if we take a look at that equation of x squared times y minus 1, x squared is always going to be positive. So that's fine. It doesn't matter what x is, it's going to be positive. And so y minus 1 is positive when y is greater than 1. Okay. Now we do also have to consider this, that if x is 0, we do get a slope of 0, which is not positive. So then what we can say is, I'm just going to write this again down here, x squared times y minus 1 is positive when y minus 1 is positive, which means y is greater than 1, but x is not 0. And so that would be the case. So it's everywhere above the x-axis except on the y-axis. And then let's find the particular solution for y equals f of x to the given differential equation. Again, writing that again, dy dx equals x squared times y minus 1. I'm going to go ahead and divide by x squared or multiply by 1 over x squared. Actually, scratch that. I'm going to multiply by 1 over y minus 1 dy. Multiply by dx gives me x squared dx. Now again, I'm looking at this denominator. It is a function. The derivative of that is 1, so there's no need for any sort of substitution. So we can go ahead and integrate here. And so the integral is going to be the ln of the absolute value of y minus 1 equals, it's going to be x squared over 3. I'm just going to write that as 1/3 x cubed plus c. At the point 0, 3, we get the ln of 3 minus 1, absolute value, equals 1/3 times 0 cubed plus c. The left side reduces to the ln of 2. The right side, everything zeroes out in that first term, so we get c is equal to the ln of 2. So our function now becomes the ln of the absolute value of y minus 1 is equal to 1/3 x cubed plus the ln of 2. Now we proceed for solving for y, so we're going to go ahead and exponentiate both sides of this equation. So I get the absolute value of y minus 1 equals, and again, because this is the exponent is a sum, it could be e to the first term multiplied by e to the second term, and e to the ln just becomes 2, and we get e to the 1/3 x cubed. Since our y coordinate is positive here, then I know the entire right side is always going to work out to be positive, so we can just drop the absolute value. Again, if it said f of 0 was -3 or something relevant there that where it's negative or something, I would need to go ahead and actually put a negative in front of the 2 here. So we can go ahead and we can add 1 to both sides. And there we go. If we needed to find the domain, because it's exponential, the domain would be all real numbers without any trouble at all. All right, that's it for number 11. Good luck on the test.